Okay, so they gave us x and x plus h, right? If I remember correctly. This, by the way, just average rate of change on x plus h. This is gonna rule your life for about a week, a little more than a week in Calc 1. So this is a problem we can obviously do at this level. And if I add one thing to it, it becomes calculus. So that's how close calculus is to algebra. It's effectively just the next step above algebra. How the shit do I do this? So I want to go from this to this. So this is x2, this is x1. So on one level, I just kind of plug this stuff in. x2 is x plus h. x1 is x over x2 minus x1, yes? What happens on the bottom of this? So that's the average rate of change formula. They gave me those inputs. I put them in, because that's what you do with inputs. The bottom just becomes h, right? The x's cancel. Do you know what f of x is? Yeah, it's this. So that just goes here, yeah? I know what f of x is. Yeah. So I'm going to minus that. You with me? So what's the only thing I actually don't know yet? Probably the one I left blank. I have no idea what f of x plus h is yet, yes? So do that on the side. How do I do f of x plus h? If f of x is 3x squared minus 2, let's do this. What's f of 4? Just out of curiosity. How do you do f of 4? Yeah. 3 times 4 squared minus 2 be 48 minus 2, 46. So what is f of x plus h? Plug in x plus h in place of x. And now what do you think you do with this? What do you think you do with this here? Yeah, FOIL it out. Get the 3 through there. You with me? So this is what's called, not what I call it, but it's a construction approach. I have to construct this. Okay, they gave it to me. I have to construct this. Okay, let me construct it, and then whatever I get, I can put right there. Get all your like terms together. It should reduce at the end. Okay. The thing you have to remember is function notation is so frickin' single-minded. It's just whatever they put in place of x, I'm going to put in place of x. Whatever they put in place of x, I'm going to put in place of x. Bam! And then you simplify what you can. So here you're going to write this twice, you're going to FOIL it out. Okay. How's everybody doing? Is that okay? You can always ask follow-up questions. I want to leave something for you to do, though.
I have a question with 3.255. You might have this in the past. Something like that. 55 on 3.2.
Hard. Hi. Let's see, 55. Oh yeah, yeah. We did. In your graphing calculator, there's a y equals button, so then you just put that in there?
Yeah.
Yes?
Yeah, well, I understand how to do it, but when I put it into my graphing calculator,
Now here's the trick.
yeah.
You know you want x min and x max. Yes? You have to by hand, not by hand, but like in your calculator, put in negative 0.5 in and put in negative 0.1 in so you can figure out what y min and y max are. So if your graph is doing, look here, if your graph is doing this and your window is set here, you're not going to see it.
Yeah.
So if you plug those in, you can see what y min and y max should be, so you actually move your window so you can see the graph. Yes? So try it. What do you get when you plug in negative 0.5 in? Yeah. 1 divided by parentheses negative 0.5 parentheses squared, right?
How did we know that we were supposed to write that?
You have to figure it out, which is the part of the problem that you have to think about.
Okay.
So they told me, these are two separate problems. So that, for example, they told me they want x min and x max. I want to go from there to there on the x-axis. The whole point was determine the corresponding range. Well, if I know what my inputs are, I can figure out what those outputs are. And that gives me an idea about the lowest y and the highest y.
Okay.
Yeah.
So I assume that the 0.5 and 0.1 refer to what we should set our viewing window to.
The viewing window involves x min and x max, and it involves y min and y max. The y min and y max they didn't tell us.
Oh, I assume those were the two numbers.
That's one problem.
Okay.
Do that problem. That's another problem. Do that problem. Yeah.
Sure.
Okay. I will agree with you. They weren't really clear on the fact that there are two separate problems here.
Yeah.
Yeah. Anything else from homework or from the quiz? Okay. The homework you guys gave me last time, I haven't graded it yet. This weekend was like, I had a test and 2 quizzes and it was crazy. So I'm hoping to do that tonight. We'll see. If there's nothing else from homework, we're going to get back into lines. Does anyone need a copy of this here if you don't have your lecture book? Everybody's good? Let me know. Anyone? Everybody else good? Okay. Follow me. Make sure you're right. Yeah. I do want to talk just a minute about this kind of thing. This is insane. You agree? This is called a scatter plot, and it kind of makes sense. It's called a scatter plot. But it's like data points. Here's the speed somebody was going, and here's the distance it took for them to stop. Yes? And do you see a trend in the data? I'm just going to say that. You guys see a trend? Does it seem to take more distance per speed, less distance, about the same? Yeah, the faster you're going, it seems to take, on average, what? If you're going faster, it seems to take, does everybody know how to read this? So like if I'm going 10 miles an hour, I got 3 data points. It took people around 18 to 20 to like 30 feet. What is this? Yes, to stop. You guys with me? So why was there a range in that? Why was the data kind of spread out? How many cars have you had in your whole life? Anybody? Have you had one car? Somebody had never had a car. I'm sorry. You've had 2. Would you say one was better than the other one?
Yeah.
Would you say one could stop faster than the other one? Or could even, I had a car that was like, I'd hit the accelerator and it would say, oh yeah. It would take it a minute to remember what it was supposed to do. So, different cars, different driving styles, different data points, yes? But even if we plot all the data points, we can still see a general trend. Now, I would argue, if you forced a line to show up, it would be something like this, yes? That would be the line that best fits the data. But would you agree with me that it actually looks more like part of a parabola maybe? Like, wouldn't that fit it better? Do you guys see what I mean? Doesn't it look more like it's curvy?
Yeah.
Especially with that guy. Do you see what I mean? So this is a big part of statistics is you take a bunch of data It's got differences because there's different things happening, different days, different people. But you can see a trend. And sometimes the trend is linear, sometimes it's parabolic. It could even be logarithmic, which we haven't talked about yet. It could be, anyway. So in this case, if I force it to be a linear trend, I could then find the equation of this line, and then I could make predictions. How long would it take on average for somebody to stop if they're going such and so fast? Okay. How would I improve the data? Make it more reliable? I'd have to, I'm assuming what this is a lot of different kind of cars. What if I just had one kind of car? I would expect these points to be less scattered, correct? But I would gain certainty, but I would lose broad applicability. Oh shit, what did I just say? It would only be applicable for people with that kind of car, yes? You guys with me? So this idea of like an averaging line makes it applicable to everybody with some wobble to it. Okay, maybe. Anyway, we're not going to suddenly become a stats class. But just to show you, in statistics, they have this idea of a line of best fit. That's the actual name of it. Okay. One thing I forgot to say, but I think we've kind of said this. That's a positive slope, a negative slope. This kind of slope is flat, so it's zero slope. And this, you either can call it undefined or you can call it infinite. Because it instantaneously just rises forever. Okay, let me stop for a minute. If you're in a car, you don't want to go up this. I'm cool with that. Hell, I might even be cool with this. Okay. So let's get to the part. So last time what we did, I introduced this equation. So can somebody help me out? You got a marker on me. What is this point? Why is this point really good? Why is the point they give me really good? Yes, the y-intercept. So what do I know? What's b? Yes. So right there I know b is -2 because b is always the y piece of the y-intercept. What else did they just tell me? B slopes. They told me the slope. So what letter is that? No. What letter is that? M. Yes. So the two things that are unknown in this equation of the line is m, slope, b, y-intercept. Example 6 is like tears. Thank you. They just told me. Oh, here's b and here's m. I'm like, thank you. So can you write the equation of the line then? Yep. What is it?
Y equals -5x minus.
That's insane. Okay. Can you guys take a moment and graph that? I'll stand up here very helpfully.
Thank you.
Cool. They were very nice with the graph they gave us. They gave us enough room. Because what do you have to, where do you start? How do you, when you're going to go graph this thing, where do you start? You start at the y-intercept. You start at any point you know is on the line. So we know this point's on the line. The slope's job is, if you are on the path, it gets me back to the path. Yes? So I start at a point on the line. In this case, the only point I know is 0, -2. Bye. And then how do I move from there? What can I do with -5 to make it better? Put it over 1, because now what's the rise? It's actually telling me to do what? What's slope again in English?
Rate of change.
I like it, but ratio. Rise over run. If the rise is -5, what does that actually mean? Going down, right? So I would start here. The slope tells me from there, go down 5. 1, 2, 3, 4, 5. And then run 1. 1 positive 1, yes? Now I could have said, isn't 5 divided by -1 the same number? Isn't that also -5? What would that have told me? Start here and go up 5. 1, 2, 3, 4, 5. And then back 1, yes? And you see how I'm still on the same line. So don't matter. Don't matter at all. It ain't no thing. So you could choose where to put the negative. Is everybody with me? I'm hoping most of you guys remember this stuff. It's not too evil. Yeah. What's different about number 7? Example 7.
Didn't give you the y.
Those jackasses. They didn't give me the y intercept, so I don't know what b is, right? Now, there's a reason. I don't know. Does anyone? All right. Well, listen. Let me just say it this way. If you happen to know how to use mx plus b to get the equation, even though we don't know b, I recommend you don't do it that way. In calculus, the more you work with y minus y1, the other equation we made, and I'm pretty sure we got there, didn't we? Where's my glasses? They're there. Didn't we get here?
Yeah.
Thank God. Thought we did. The more you work with that directly, it actually directly ties to a couple things in calculus. Does somebody remember what to put where? Obviously, what goes here?
-3.
Yeah, I know the slope is -3. Now, what goes here and here? What does x1, y1 point to? Kind of gave it away. What's the other thing I know?
4, -2,
So what's this?
x1.
That's y1. So it'll be y minus y1. What's y1? -2 equals m -3 times x minus what's x1? 4. Kick ass. Oh yeah, that's right. So I mean, last time we did an example like this on that handout I had. So hopefully this isn't too freaky. What can I do here? Distribute. And then subtract. Now let's do this. Pretend like we don't know this. Can you graph the line using just what they told us? All right, take a moment and graph the line using just what they told us. And if you need a copy of this, I have 3 left. By the way, let me check. Are my 2 Dawudzes? Is that how you say it? Dawood? Yes? What's your name?
Abdul.
Abdul. Yeah, you're Omar. Yes? Okay. And you're, is it Samir or is it Red? It's Samir? Okay. Thank you. So it doesn't matter if it's the y-intercept or some other point. To graph a line, I start on the line. So the only thing I know that's on the line is 4, -2. And then where do I go from there? How do I move from there? What's the slope? Negative 3 over 1. Cool. So I could go how from here? Down 3 over 1, yes? Or I could go up 3, back 1. I'm going to do that a few times. Up 3, back 1. Up 3, back 1. Up 3, back 1. What point did I just get to?
0, 10.
And what's the y-intercept? 0, 10. Y-intercept to point, right? You never have to do what I just did, by the way, but I just wanted to show you the connection between. Well, if we just graph this, there must be a connection to this. And sure enough, I get the same y-intercept. Kick ass. And now it should be easy for me with so many points. That's pretty good. Okay. So the slope is negative, it's going down. It does hit 10. Kick ass. Maybe. So for a decent number of us, this should be review. But for some of us, maybe it's been a while. I know a few of us haven't had math in like a couple years. And it leaks out the brain the quickest. Okay, so this was all on that sheet we did, but I just wanted to kind of review that. How would I do this? I think we did one like this. How would I get the equation? Did they tell us the slope? Did they tell us the slope? So I don't know the value of what letter? M. But I do know x1, y1. In fact, I've got 2 frickin' points to choose from. It doesn't matter which one I choose. So I've got one thing I need, a point. So whenever they say find the equation of the line that, I need 2 things. I need a point. We definitely got that. And every now and again I have a point. And I need the slope. So we got a point. Which point do you want to use?
-4.
Alright, -4, -8. Brave man with all my negatives. I love it. I got that. Check. Do I have the slope? No. Shit. How do I get the slope? y2 minus y1 over x2 minus x1. To be really honest, it could be y1 minus y2 over x1, as long as the subscript's mentioned, right? So take a minute, figure out the slope, and then try to get the equation of the line put together. You have to use, you don't have to, but you should use the one we just used. Let me catch up with quizzes. Is Joey here? No, Joey. Isabella? Isabella? The other Ethan? Basharwa? And Dylan. Dylan? Real quick, this is the sheet we worked on last time. Does anyone need a copy of this one? You can watch the video from last time. Anybody else? Okay. Oh, you got it already? I know what's yeah.
They have a someone for.
Oh, this one. So it doesn't matter what you choose 1s and 2s to be. So if I do -2 minus -8, over 8 minus negative 4. You guys see, some of you guys might have made this mistake. Your brain says, oh, there's already a minus there. But the minus is in the equation. If that's negative, it's got to be minus and negative. Yes? Our brain sometimes goes, I already wrote a minus. Well, yeah, we did, brain, because of this stupid thing, but this is negative, so I need 2 negatives. Because then what happens here? Negative 2 plus 8 is?
8, 6.
6. And then these, of course, become? And what's 8 plus 4? 1. Which reduces to 1/2. Is that cool? So now we know n. You guys picked a point. Yes? In fact, here. Has everybody done this already? You guys to put this together? Has anybody done that yet? Have anybody put their stuff into this equation yet? Alright, so now we know x1, y1, and we know m. So now it's just a matter of plugging it in, right? Almost too good to believe. You just have to shove them in. You guys help me. So take a minute and do that. I'll do it in a minute, but I'm going to use the other point and show you everything. Yeah. So putting stuff in, it'll be y minus the y piece equals m times x minus the x piece, right? I did just say I was going to use the other point. I will in a second. So it becomes plus 8, that becomes plus 4. If I distribute the 1/2, and then my last step is subtract 8. So if I do all that again, but I use the other point, so y minus the y piece of the other point equals m times x minus the x piece. This will be y plus 2 equals 1/2 x. What did I just do? 1/2 x minus 4. And then if I subtract 2, I get 1/2 x minus 6. Jeff! Oh gosh. I'm sorry. I'm kind of tired. Is that alright? I get the same exact answer. Of course I do. Because I used the same slope and I used a point on the line. How many points does every line go through? Infinite number of points. And the line goes through an infinite number of points, yes? You guys with me? No? Screw you, Jeff? So if I plot -4, -8, and I plot 8, -2, there's my line. Yeehaw. And we just said the y-intercept is supposed to be -6. Look. Yay. So I need you to understand something weird. Do you see every point that this line goes through is a point that works in the equation? Yes? So it goes through an infinite number of points. It goes through an infinite number of points from here to there. There's an infinite number of points in between those two. That is trippy as shit. Is everybody cool with that fact? There's an infinite number of points from here to there. There's an infinite number of numbers between 0 and 1. Yes? You can think about like cut it in half, 1/2. Cut that in half, 1/4. Cut that in half, 1/8. How long can you keep doing that? Forever. So there's an infinity of numbers already. Okay. Infinity is weird. Let's try a couple of word problems out. Not really word problems. You'll see what I mean. I want you to read through number 9. Okay. This really kind of sucks because they chose T for both things, right? Upper and lowercase. So when you answer this question, say upper or lower, right? Uppercase, lowercase. Which one is acting like Y? Which one is acting like the input? Do you see this? Do you see it's in the form M plus B? So which one is acting like Y?
T.
There's 2 T's, guys, remember? Lower or uppercase? Which one's acting like Y?
Uppercase.
Uppercase T is acting like Y. Lowercase t is acting like X. Is everybody with me? Because then it would be Y equals MX plus B. So the choice of upper lowercase t was dumb. It's okay. We're going to be okay. I kind of like it because Y and X are arbitrary. There is an interesting history as to why X was chosen. And then since we chose X, we just went, what's the next letter? Y, okay. And then that's why we chose X and Y. It didn't have to be that way. It totally didn't. So the letters we use don't mean shit. We normally use, when we have a situation, a real life situation, we use variables that relate to the thing. So it kind of makes sense since I have temperature and I have time. It does make sense to use the letter T twice. It does make it harder to talk about the damn thing though, so I'm going to have to suggest an edit to our book people. Okay. What is the slope? So let me put this, sorry, let me do this. Temperature, capital T, is acting like Y. Is that cool? And lowercase t, time, is acting like X. What part of this equation is the slope? 0.02. Can anyone tell me units on that slope? You can do this. How do I get the slope? In English, what is it? Rise or run. The rise is the Y's, yes? And the run is the X's. So here's what's funny about units for slope. What's acting like Y? Capital T, temperature. And what's acting like X? Time. That would be years, yes? So this is Y over X, change in Y over change in X. So what's the units on the top? Units. Celsius degrees per year. There you go. I need you to see. If I ask you for units on slope, it's easy as shit. You just go, what's acting like Y? What's acting like X? Y on the top, X on the bottom. Done. So the slope as a number is 0.02, but that means Celsius degrees per year. So that's how much the temperature is rising per year. You guys all with me? And here's the thing. Whenever I talk about temperature, global temperatures rising, well, not whenever, but sometimes there are people saying, this is not political at all, this is data. No. The politics is how much do humans cause this to happen. There can be zero discussion about is it happening, because it is, but there is I can allow for a discussion about why is it happening, right? And you could be wrong if you want to. That's okay. No, I won't do that. Sorry. I'm going to try to stay away from the politics of the shit because it gets a little crazy and I don't want to. I don't want to know. blah, blah. So the slope in the context, so if you just give me the units, so you could even say, so can somebody make a sentence out of this? I basically just did.
Every year since 1950 is 0.02 degrees Celsius.
Yeah, on average, every year, temperature goes up 0.2 degrees Celsius, yes? So slope kind of, this equation is sort of, I'm assuming it's like an average, sort of like I did earlier with the line of best fit. Because you know there's going to be other reasons for the temperature to go up and down, but overall the temperature is going up like crazy. What in the hell is the capital T intercept? Capital T is acting like Y, correct? So what's in the right place to be the Y, the T intercept, the capital T intercept? Huh?
It's years since 1950, so it would be the year.
No, but look at the equation. What's the capital T intercept?
0.15.
Yeah, okay, good. 0, 15. You guys see that? Because this is like y equals mx plus b. That's the intercept for this variable. What does it mean? Can somebody tell me? A point is normally x comma y, correct? Can somebody tell me what this point actually is? It's not xy, is it? What is it? Don't say tt, dear God. What do we say is acting like x? Lowercase t. So this would be lowercase t, uppercase t. So, if you remind yourself of that, what the shit does this mean? You are basically just saying this. Little t means years since 1950. So how many years since 1950?
0.
So what year is it? In 1950, what does this mean?
Average temperature Celsius.
Yes, average temperature in Celsius degrees. Cool. You guys kind of with me? That's the other thing I had to do, because this is, anyway, the numbers are a little off. It should be 14 point something, but it's okay. I'll be here. It's close, 50 is close. So everybody with me? You guys see how to do this? So we are going to have problems where they give us an equation. It's not necessarily going to use x and y, but you can identify what's acting like x, what's acting like y. How do I do part C?
Plug it in. That's years.
Plug in 100 where? Where'd you get 100 from?
So the year 2050 is 100 years since 1950. So that would be
Exactly. And which variable controls that?
lowercase.
Lowercase t controls that. Is that cool? So lowercase t is years since 1950. So to calculate this, I'm going to plug 100 in. Now that's making a huge assumption. That's assuming that this continues like this. But if it does continue, and very quickly, I just have to say this, just in case anybody out there is confused. Again, I have to walk a fair fine line here. People will say, man, like 30 years ago, they said in 10 years we're going to be underwater the whole world, and it didn't. Well, that's because things changed. You guys weren't alive in 1990, most of you guys. Was anyone alive in 1990? Just me, just this guy? Okay. That was about the time people really woke up to the environment. And there was a huge movement, Earth Day became a huge thing. That was about when that happened, to be honest. So we started changing a ton of shit. We cut down on chlorofluorocarbons that actually eats away those. We changed a lot of shit. So yeah, there were dire predictions. We thought by the year 2000 California is going to be underwater. But then so many things changed. So of course that didn't happen. You kind of with me? So a lot of times, and again, I'm not trying to tell you how to think. I'm trying to tell you how to analyze what people tell you. If they say, well, they said it was going to be bad and it wasn't, say, things changed. We actually did stuff. Yes? That you can still argue about whether humans are causing or not. That's fine. You can argue about that, but okay, I'll stop. So T is 100, and I want to predict this. So this is what I don't know, and that's capital T. So in my equation, I want to know what capital T is when lowercase t is 100. So I just have to plug it in. Does anyone know what point, did I write that right? Yeah, 0.02 times 100 is? Yeah, you guys know when you multiply by 10, you move the decimal once. So if you multiply by 2 tens, you move the decimal twice. So that's 2 plus 15 is 17. Now, that sounds very small, yes?
Yeah.
That is insane. If the average global temperature was 17 degrees Celsius, holy shit. Holy shit. That is hot. I mean, average global temp everywhere. Yes? Sorry. I'll stop. I'm gonna focus on the math, I'm sorry. So there's like geology here, there's politics, there's environmental science. We'll focus on the math. So that's the answer. 17 what? 17 what? Degrees Celsius. Good guess, because that's what capital T is. If reptiles begin to die off when T is 17.5 degrees Celsius, when will this occur?
2075.
How'd you figure that out?
So
Yeah, because
you can just do it in your head easily, but you could set T to 17.
yes. So T is 17.5, and they want to know when, which is little t, yes? Little t is time.
We'll give you years.
So now I got to solve for little t, yes? You guys see that?
Yep.
Okay, good. So when you plug shit in to an equation, you have to know where you're plugging it, correct? Most of our equations are going to have two variables, so you have to know where to put what you're looking at. If it's temperature, I put it where the y is, so the big T. If it's time, I put it with the little t's. How do I solve this? Subtract the 15? I'll do that way instead. So that'll be 2.5 degrees. Okay, we don't need units. And then how do I get t by itself? Divide by 0.02. 2.5 on 0.02 is 250 divided by 2 is 125. What does that mean? What does t equal to 125 mean?
That's one. That's the amount of years we're left.
That's the year since?
The reptile.
Year since?
Oh, 1950.
So what year is it? What year is it?
2075.
2007. And you're sitting there like, oh, it's not me, Colorado. No, overachieving. No, you guys kind of is that cool? Sorry. So this is what sciences do with mathematics. They make observations, they set up equations, they make predictions. The predictions weren't wrong just because they didn't come true, because they were based on models that weren't accurate anymore because we made changes. Thank God we continue to make changes. Recently, I don't know. No, I'm sorry. I'm going to keep that out. It should be political, but it is, so I got to stop. Okay. Okay. Let me do one more that's a little more interesting. Look at, let me see. So which one does what I wanted to do? Oh yeah, well, look at example 10 real quick. And then I'll do, let me see. Read through example 10. Oh yeah. Example 12 will be good. We'll do another candle problem. So they gave us the letters they want to use instead of Y and X. So if I'm you and I'm getting used to this whole stuff, I want to do what we just did. Which letter is kind of like acting like Y? Can you guys tell?
Cost.
Yes, cost is acting like Y because they're telling me S is the input. So cost is acting like Y. And the amount of sugar is acting like X. So this would be like C of X. What information did they give me?
How much it's going to cost without any tons?
Yeah, so no matter what, if I rent a truck, even if I drive it for 0 hours, how much does it cost? Yes. If I rent a truck for 1 hour, how much does it cost? I'm sorry, it's not hours. If I rent a truck and transport 1 ton of sugar, if I transport 2 tons of sugar, let me see. Every ton of sugar count increases the cost by how much? Do you guys see how that's an average rate of change? How that's a rate of change? That is $225 per ton of sugar. That is delta y over delta x. That's the slope. You guys see that? Very often, if I see the word per, I'm gonna be really careful, but most of the time that's gonna be my slope. So additional 225 per ton for each would be per. So that's my slope. So here's what I'm trying to say. If I do 0 tons of sugar and I just drive the truck around just because I want to, that's going to cost $4,500 by itself. Yes. If I do 1 ton of sugar, 1 tons, sure, Jeff. That'd be $4,500 plus 1 of these. Yes. If I do 2 tons of sugar, how much is it going to be? How many of these? 2 of these. What would that be, smart boy? 5,000? No, 4,950? Yeah. Way to go, math boy. And so what if I do S tons of sugar? What will it be? 4,500 plus? No? 225 S. That's why I don't use S. Look at my 5 and my S. So the cost will be 4,500 base amount plus 225 per ton of sugar. Hey, look at that. That's the best S I ever made in my life. And you guys were here for it. Look at that S. It's totally different from my 5. That just never happens. Sorry.
You get a gold star, Jeff.
All right, shut up. Right, so horribly, I gotta celebrate. Is everybody okay with that? So it's like, I like to give students a problem like you call the psychic hotline to see what's gonna be on the next test. And it costs $80 just to call and then $2 each minute. So it'd be 80 plus 2 times X. $80 base amount plus 2 per minute. Are you guys kind of with me? This is a very classic way to get a linear equation. It's a base amount plus amount per time or per, in this case, ton. Okay, maybe. How do I use the equation to find the cost to transport 14 tons? Oh, sure. What do I do? Good. S is tons of sugar. 14 tons of sugar, I'll replace S with 14. What'll that be? I don't know. 2250 plus 900, 3150, 7650. Is anyone doing that for me? Is that what it is? Yay, look at me! Sorry. So, it's my one skill. So the cost of 14 tons, 14 is my input because S means tons of sugar. Man, I messed up my perfect S. And if you just shove that in the old calculator, it's whatever I just said, which I already forgot. I already forgot what it was. 7650? Yeah. Okay. That's all it costs. So in case you were curious, I need to get 14 tons of sugar to my friend's house. It's going to cost that much if you use this company. Okay, so we finally answered the question for you. All right, I want to do one more of these real quick because you're going to see this next type is definitely going to be in the homework. This candle problem. Read through this. They give us the information in a different format. Read through this. what sucks about how they gave us information? The other problems we did, they told us things directly. Did they tell us directly what the slope is?
Nope.
Did they tell us directly what the y-intercept is? No. What did they tell us?
2 points.
In this case, can you guys see what's acting like y? What are the two variables they're using? Can you guys see? Look at part A. Yeah, they're using h for height and t for time, which makes sense. Which one acts like y? H, because t is the input. Yes, so that's acting like x. Are you with me? So do you see 2 points of information? Alright, right? Time is like the x, height is like the y. So what's 1 point of information they told us? Is there a time and a height that go together? So you can make the point, write a point, 11, comma, 18.8. Do you see another point of information?
27 and 15.6.
I like it. Somebody just has this candle just going. I think it's one of those big old candles, right? Just take forever to burn down. Because that's a long time. I want an equation of a line. When you see linear model, that's just another way to say equation of a line. And of course, what did we figure out? What do you need to get the equation of a line? What 2 things? Slope and a point, right? We have 2 points. You can pick whichever one you like better. If they both suck, too bad. You gotta pick one of them. How do we get the slope? Sure, that'll work. y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. As long as it's the same way on top, bottom, you're good. So my slope is going to be output minus output divided by input minus input. Oh my God, what is that? So we'll get 3.2 over negative 16. Do you guys see that? What's 32 divided by 16? 2. So what's 3.2 divided by 16? Don't overthink it. 0.2. Yeah. So this is negative 0.2. Can we write that a little bit better? What does 0.2 mean as a fraction? 2 whats? Do you guys remember? 2/10. And what does that reduce to? There we go. That looks more like a slope, right? Rise over run. So how do you get the equation? So for me, if I were you, height is like y, time is like x. So I would do the work with y and x, because that's what I'm used to. And then at the end, I would replace y with h, and I would replace x with t. So what's the equation of a line that we're going to use?
Y minus y1 equals
Totally. So y minus, which point do you want to use?
11.
Good.
18.8.
It doesn't matter, but that's what I was looking at. So y minus the y piece equals m times x minus the x piece. Now that's gross, yes? Too bad. So then we get that, and then if I distribute this through, I've got like decimals and fractions mixed up, but that's okay. 11/5 is 22/10 is 2.2. So if you did in your calculator 11.5, you would get 2.2. Is that cool? Just so I have decimals matching with decimals. And now what's my last step here?
You add 8.
Yeah. So I get y equals negative 1/5 x plus 21. What do I replace y with?
A capital H.
Yep. Height is negative 1/5 time plus 21. Can anyone tell me, well, it's part B, I just noticed. What was the candle's initial height? How tall was the candle before I lit it? How did you know that?
Because it
Yeah.
says slow.
When time is 0, no time has passed, it's 21 centimeters tall, right? Centimeters, yes. True. You guys got with me? And then the other problems we basically did before. I just want to show you how to set up the equation given 2 points of information. Okay. So, see the slope and we already did all this. Okay. What I'd love to do. Okay. Let me see. I didn't bring any of it. It's okay. I'll be all right. Yeah, let me do this in a minute. Maybe I'll run and get some. Christine, could you see if you could borrow some markers from the Math Science Center?
Yeah, like how
And
many?
you can help when I put them up on the boards.
Oh, how many-ish, do you know?
1, 2, 3, 4, 5, 6.
Oh, alright.
Thank you. Okay. So that is the end of chapter 4. So the application stuff, the stuff we just did, like the candle and the sugar, that's section 4.2. So we only did 4.1 and 4.2 from chapter 4. We're now going to get into quadratics. When I say the word quadratic, what comes to mind? Anything?
4.
Do it again.
4.
I like it, 4. Sure, quad, right? Especially if you've ever ridden a quad. You think 4. What about, like, purely mathematically, when you hear the word quadratic?
Formula.
Quadratic formula. Yes? Does anyone remember the quadratic formula? Not specifically, but do you remember talking about it?
Yeah.
Negative b plus or minus blah, 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 blah.
Yes? We're going to prove that. Yay, I can't wait. Okay, I like this. So 4, because quad, that makes sense. Quadratic formula, that's what I normally expect to hear somebody say, because I'm almost certain you guys have all done the quadratic formula at some point. And it was so desperately exciting. Okay. Why the shit do we call it quadratic, which means 4, when what does a quadratic equation look like? Quadratic expression, what does it look like? Does anyone remember? What kind of equation do I use the quadratic formula for? And I'll help you out. Like this, that's quadratic. What's the power? 2. Second degree? Is that okay? You guys with me? Can anyone see the problem? Why did us math geniuses that are supposed to be really good at numbers, why do we call this a quadratic if it's got a second power? Is anyone else concerned about us? You're all weird. Just, I don't worry about you. Watch this. Just to make sure everybody's with me. What is the area of this rectangle? Is everybody cool? You with me? What's the area? And how many sides does this have? Holy shit. So what is the area? I'll draw a better triangle, rectangle. What is the area of this rectangle? Go ahead, I'll wait. What is the area of that rectangle? Don't say it, try to do it. You do, it's the same problem, right? It's the exact same problem. You guys all cool with where 35 came from? Where did we get it from? Yeah, area of a rectangle is length times width. What's the length now for this one?
X plus 2.
What's the width?
X plus 3.
All right, whatever you call it. What? You're going to multiply those together, yes? All right, I don't see enough people writing. I want to know what the area of that is.
X squared plus 5x plus 6.
It's that, right? So do you see now why they call it quadratic? Because a lot of the early exploration of mathematics, a lot of it was related to astronomy, but most of it was visual. And they knew that this expression, x squared plus shit, came from if I called the sides of a rectangle, and it's got 4 sides. So of course they call it quadratic. It came from a 4-sided figure. Do you guys see what I'm saying? But I don't blame you on the surface. You should be a little concerned. Quad 2. Okay. But now you see better. Okay. So we're going to investigate how to solve formulas where this is equal to a number, for example. So let me do the most basic example here. Can you guys, here, just to kind of get us on the right track, if I told you that 2 numbers multiply to be 8, do you know what either number is? Can you tell me what either number might be? Say again. Okay, so one possibility is 2 and 4. Give me another one.
1 and 8.
1 and 8. Give me another one.
-2, -4.
-2, -4. Give me another one.
-1, -8.
Give me another one. 1/2, 16. Give me another one. Give me another one. 1/10 and 80. -1/10, -80. How long could this go on for? For the rest of your lives, and the rest of your kids' lives, and the rest of their lives, and the rest of the other kids' lives. Okay, right? Okay, so there's an infinite number of ways to get an answer for this. Does everybody agree? Okay. What about if 2 numbers multiply to be 0? Is there anything that must be true?
Yeah.
One of them has to be 0. So either what?
X is 0.
Either x is 0 or y is 0. Definite,
Or
indefinite. Finite number of answers? Nah. You with me? So watch this. What if I had this equation? Do you guys see how that's 2 numbers? What is x plus 2? A really good answer right now would be I don't know. But what does it represent? It represents a number, correct? If x was 3, it would be the number 5. What's x plus 3? What is x plus 3? What's x plus 2? A number I don't know. What's x plus 3? Another number I don't know. So there's 2 numbers that multiply to be 0. What must be true? One of them has to be 0. So what could be 0? Either what?
x equals -2.
No. Either, I know where you're going. You're good.
X plus 2.
Either x plus 2 is 0 or x plus 3 is 0. Are you with me? So x is -2 or, right, subtract 2, or x is -3. So everybody with me? So what if instead the equation had been this? Yes? Do you understand how this sucks bad?
Yeah.
Does either one of them have to be 8? Could one of them be 4 and the other one's 2? Could one of them be 8 and the other one's 1? Could one of them be 16 and the other one is 1/2? Yes, right? Do you see what I'm saying? No. So when I have a squared in my equation, I very often want to get it equal to 0, because then when I factor, I can get exact answers. I don't just sit here and go, well, it could be this, or it could be this, or it could be this, or no, screw that. I want to know one of them is 0, and then I get the answers. Yes? Is everybody with me? So that would suck. That would suck bad. So what would I do? This one actually is really gross. So let me make one that's a little better. What would I do if I had this here? What would you do? There we go. That should work out. It's not equal to 0. It's supposed to be equal to 0. Damn it.
Subtract 21.
And before I do that, I could do one thing. I want you to realize this is like somebody factored too early. So I'm gonna unfactor. I'm gonna multiply stuff out. And then I can incorporate the 21. So what do I get when I multiply this stuff out?
X squared.
Plus 2x.
Plus 3x minus x. I'll catch up to you. So I get x squared plus 2x minus 3 equals 21. And then what can I do?
Now subtract.
Now subtract 21. Now what can I do? I want you to realize, if that wasn't there, what would you do?
5 greatest common factor.
No. Well, no, not really. What would you do? Come on.
You add 24.
Add 24 divided by 2, yes? So if I can get all my x shit together, I can get it on one side and get the numbers on the other side. Can I get all my x stuff together? Because they're not like terms. Whenever you have different powers on your x, you want to get it equal to 0 and try to factor. Can you factor this? What do you need? Two numbers that do what?
Multiply by
So it's not too bad.
-4 positive 2.
Yeah, right? 4 and 6. If the 4's negative, it'll come out positive at the end. So what's my answers?
X -4.
Careful.
X equals 4.
So either x minus 4 is 0, add 4, x is 4. So on sight, you can tell what would make this 0? 4. What would make this 0? Negative 6. There we go. So how did I make this problem? How did I know it was going to have nice answers? Because if I would have just pulled numbers out of my ass, it would have been gross. It would have been weird. What happened today? Well, that teacher pulled numbers out of his ass. I chose a number. I chose 4. So I wrote this and I wrote this, and then in my head I said 4 minus 1 is 3, 4 plus 3 is 7, 3 times 7 is 21. So I knew it was going to have nice answers because I chose a nice answer. The other answer I didn't know was going to happen. The other answer was negative 6. What's negative 6 minus 1? Negative 7. What's negative 6 plus 3? What's negative 7 times negative 3? Hey. But if the number isn't 0 here, there's too many possibilities to check. If it is 0, I can zoom in on the answer directly. You guys see that? Okay, so you have to have it equal to 0 when it's got higher powers on the ends. Okay. I'm really sorry. Every now and again I have to talk a lot. And that's today. Yay. So watch this. I could just give you, how do you do this problem here?
Add 4.
Oh, I see. You could, but trying to lead you in a certain direction. Can you factor that?
Yeah.
So what are the two answers? Now, where you were about to go was you're about to do this. If you add 49, you get x squared equals 49. But normally when I do that, people tell me there's one answer. How many answers do we know there has to be?
2.
2 freaking answers.
So you just put the plus or minus in front.
Yes. When I all right, here's the key thing. I mean, literally, what do you square to get 49? Not just 7. Negative 7. Do you guys with me? So when you take a square root, you have to put plus or minus. And this is actually kind of huge. This happens often enough that you really never want to forget that. It has to be second nature. When you take a square root, immediately put a plus or minus. And you can see why. That's the only way to make sure I get all the answers. Now, to be really honest, we haven't done that yet. Shit. I can't do it that way. Okay, I'm not going to do it that way. Yeah, we haven't done absolute value equations, no. That's in our future. Yeah. Okay. I'll do that. I'll do this problem again a different way. So I want you to notice something. How would I do this, for example? I mean, that's a nice one, yes? Say again?
Square root.
Square root, and I immediately put what?
That's not sure what it is.
I'll do this side.
That's what it
There, okay, good, right? Oh, there they go. I love it. All right. You guys are here, it's good. How do I do this?
Add 16.
Square root. What's the square root of negative 16?
Plus or minus 6
Not 6.
That's 6.
or 4.
You guys with me? We know about complex numbers. Yes? Okay.
Is
All right. So let me show you one more thing here. Do you see how it's okay if I get real or complex? I mean, it's the same steps. So what about this? I need you to start to understand. Would you FOIL this out? Do you see how you shouldn't? Where's my x? It's inside of a square, correct? How do I get it free? Same thing we just did. Take a square root, right? I could FOIL it out, but that's the long way to do this problem. Take a square root of both sides, and the minute I do that, so these kill each other, yes? Can you simplify 12, add 12? Of course you can. Don't do 2 times 6, right? You want a number you can do the square root of. So what's 12?
4 and 3.
4 times 3. So what do you get? What's the square root of 4? 2. Square root of 3? I don't know. And what's the last step?
Minus
No.
2. Plus 2.
Add 3. And I always shove the 3 in front to keep the plus or minus in the middle. Shabow! So if you guys remember quadratic formula, that should look like an answer you would get from quadratic formula. Because all quadratic formula does is, if you can't factor it, it's how you solve it. Yes? Okay. So, if something is in this form, stuff squared equals number, I can solve it very quickly. Yes, sir?
This is a suggestion. Do you think we could zoom out a little bit more so we can see the whole
Sure, of course.
Yeah.
Yeah, I'm not doing it to be evil. I am generally evil, but I don't do that to be evil. Okay. So here's what I'm trying to build up to. And here's what I'm going to have you guys do on the board for me in a minute. If I have, what do you got, Jeff? Yeah. Do you see, if I subtracted the 3, can I factor this? Oh, neat. How do you factor it? Teach me. Because what would I need? I would need 2 numbers that do what? You can do it. What do I need to factor this? I need 2 numbers that multiplied in negative 3, add to 10. No. You with me? So screw this. If only there was a way to make this become this, then we can do what we just did. We could square root both sides. Now, I don't blame you if you're like, what are you talking? I would never think about that with this shit. But if I could, then I could just square root both sides, yes? No problem. And we officially don't know quadratic formula yet, so don't be telling me use quadratic formula. We don't know it yet. We haven't proven it yet, so you can't use it. So what I want you guys to do, let me see how many people have. 4, 8, 12, 15. Almost, okay, almost. 15, this is good. Groups of 3. How many markers did you get?
A 6.
Oh, that makes sense. All right. Let me see. Oh, this is perfect. Okay. You're going to be different color teams, yes? I like this. All right, how do I to do this. My orange team. So orange people, orange, go to that board back there. So you're orange. So are you. So are you. So are you. So you guys go to that board. I'm sorry, how many did I put forward? You're good, stop. Don't, you're not orange. You're good, keep going. I want 3 on a team. You will be forest green. And I want forest green to be in that middle one. You're forest green. You're forest green. You're forest green. That's good. I want 3. So forest green in the middle. Just get there and wait. I'll tell you what to do. Blue. Put in, you're blue. And you're blue. Who else is forest green? Can you guys get up for me? Or else I'm going to put you on with several colors. Forest green, be here. Okay. You're green, and you're green. And you guys are going to be right here. And then who do I have left? Here. You're blue.
Yeah, you.
I'm sorry. When I say green, I'm sorry. Whoever just pointed to, you're blue. Okay. Go right there. Go over there. Dark blue. You're black. And you're black. And you're black. And that's it. And then everybody left is light blue. So you guys go here. I'll turn off the projector. And my light blue people, whoever's left, go over here. I should have recorded what I was saying, but too bad. Thank you, thank you. We stole these markers, so maybe do that so we don't get in too much trouble. Oh, sure. I mean, you could ask for them. I have little racks here. There's an eraser here. Yeah, no worries. Anytime you wish you had something, just ask. It's great. All right. Whoever this group is, I'm sorry. We got the work over there. We can reference. I like the light blue. It's very nice.
Do you need one, Jeff, or?
Huh?
All back? Do you need at least one or no?
No, I'm good. Thank you, Christine. Probably will regret that decision in a minute. We'll see. Okay. So we're about to develop a method that is used in so many places. It's called completing the square. Does anyone think they've heard of that before? Some of you guys, okay. So, I'll give you an example. No, that's a bad example, we just did that. So basically, I want to figure out, what do I need to put here so that the result factors as something squared? So if we look at what we did, the 3 is half the middle dude. The 12 is half the middle dude. The -7 is half the, yes, right? No matter what. I could have put whatever the numbers I wanted to, they would have worked exactly the same way. Is everybody with me? And then, so to get what's in here, I just take half the middle dude. How do I get what I have to put at the end? I take that number, I just got half of this guy, and then what do I do with him? No. Square. What's half of 24? Half of 24. 12. 12 squared is 144. What's half of -14? -7 squared, 49. So up here, what do I do to figure out what goes here? No. What do I do to figure out what goes there? What's the 2 steps? Take the middle one and do what with it? Cut it in half. Half of the middle dude is 4. And then, what do I do? Half of -14 is -7, squared is 49. Half of 6 is 3, squared is 9. Half of 8 is 4. 4 squared is... That's the number that goes here. Yes? And then how do I factor this? The great thing is, this is not hard to factor, you agree? We are going to see problems that get harder to factor. The great thing is I never have to actually do any work because this dumb thing tells me how to factor it. That's the number that goes here. I don't even have to think about it. But is that true? So you see why we call it completing the square. I want to know what number can I add so that the result can be factored as a square. So I want to complete the square. Is that cool? So I don't know. I wanted you up out of your seat. I thought this might be good to kind of point, and you guys did it, so you can see what went into creating it. So I'm hoping you can buy into this procedure, and you have to. It's just 2 steps, but you have to memorize them. So how does this work? Let's go back to this problem here. Let me write it again. You see I have some room here? And I have the 3 over there. How do I figure out what are the 2 steps to try to make this thing look like this? What are the 2 steps? Take the middle one and cut them in half. What do you get? Okay. And then I take that and I square it. What do I get? What's a little weird is the second dude. Now, here we got to be careful. This was a little loose what I did earlier. It wasn't really an equation. It was just an illustration of the process. I have an equation now, don't I? What am I about to do with that 25? No. What do I need to put here? We just figured it out, correct? I'm going to add 25 to this side of an equation. So what do I have to do at the same time? I have to add 25 to the other side. Good. How does this thing factor now? Don't even think about it. X minus 5 squared. The first guy tells you how it's going to factor. The second guy tells you what to add in the first place. Yes, sir.
So is the right side even higher?
What do you mean? This is 28. It matters in the sense that it's going to be part of the answer, right? Because what do I do now? What was the whole point? Let me write this again because I gave myself too much room here. What's the whole point of this? What do I do now? Square root. I square rooted, so plus or minus. These kill each other, so on this side I get. Can you simplify this? Can you break 20 up into something you can do the square root and something else? How do you factor 28? 4 times 7. What's the square root of 4? 2. What's the square root of 7? I don't know. And what's the last step? Hiya! Alright, so if you ever get an irrational answer, that means even if you would have subtracted a 3, you would not have been able to factor it. It doesn't use nice whole numbers. Hi guys, so does anybody feel like they've maybe seen this before? Out of curiosity? Okay. Does anyone like, I think I've seen it before, but I completely forgot. Has anyone never seen it before, but it makes sense? Has anyone never seen it before and it makes no sense? Okay. Thank you for lying if that's true. Okay. But no, if it doesn't make sense, let me know. Let me give you this handout. And I want you to try, so I got 2 examples up there for you. I want you to try number 1 there at the bottom. And we'll do number 2 together. I want you to try number 1 out. Call me or Christina over if you need some help. Try out number 1 there at the bottom. Oh, what's up? So you can look at the examples if you need some help, or you can call me over. Or Christine. Maybe I'll do it. No. That's pretty good. Yeah. Yeah, that'll work. So, real quick, just make sure everybody did the first step right. What's the very first thing you do in number one? Add 11. Make root. Get that out of the way. That number's the bad number. It's not what I need there. Oh, let me start you back up. Yep. So then after you do that, what do you do next? Yeah, oh shit. There. So the first step, take half of the middle dude, and then what do I do with that number? Square, yeah. What do I do with this? Yes, good. The most common mistake is people forget to do it to both sides. Do my little side work here. How does this factor here? And now we're golden. Now we can do like we did earlier, right? What can I do now to both sides? Square root both sides. I square rooted, so I better put plus or minus. Can I break up 20 into something square rootable and something else? 4 and 5. I'm going to add 3 plus or minus square root of 4 is 2. Square root of 5, I don't know. Crazy sauce. All right, so let's do this one together, and this will be the last thing we do today. Now, I want to point something out. I haven't said this yet. completing the square is hardwired based on this being a 1. If that is not a 1, the way completing the square is set up will not work. So is there a problem in number 2?
Yes.
Damn it. What's the problem?
It's a 9.
It's a 9. So it's an equation though. So can I make the first number a 1? What can I do to everything to make the first number a 1? No. How do I get rid of the 9? Divide by 9. Yes? Now, we're not going to get pretty things. But you know, do damn back. X squared plus 3x, leave some room, equals 5/9. So, here's the great thing about complete square. It's a brute force process. What do I mean by that? Is anyone excited about this? What's already showing up? A fraction, yes? Does anyone know we're going to have some trouble with 3? Because what's the first thing I have to do with 3? Cut it in half. So take half of it, right? Don't use decimals, dear God. So the first step is take 3 and cut it in half. What's the second step?
Square.
Take that and square it. What do I do with this? What do I do with this? What do I always do with this? Add it. If I add it here, I better add it here. Now listen, so far, have we really done anything difficult with fractions? Do you agree there's a lot of fractions? Have we done anything much with them at all? No. I squared 3 and I squared 2. Ooh, right? I haven't really done anything with them, yes? In fact, if I just gave you this problem and said factor this, it's okay for you to come up and kick me. But here, why do I not care? I know how this factors. What do we say? What tells me how to factor the damn thing all the time? How does this factor? How do I factor this? X plus 3/2. I don't square, right? I don't have to think about it. The first step in completing the square is what will go into the factorization. I don't have to think about it, and that's awesome. Before it was dumb, because I'm like, these are easy. I can factor these. Now I'm like, thank the gods. I don't have to factor the damn thing. I just have to put a plus 3/2. But if you notice, does that make sense? 3/2 times 3/2 is 9/4. 3/2 x plus 3/2 x is 6/4 x is 3x. What did I just say? 6/2 x is 3x. So it does work, but I don't want to think about that. But I don't have to. The first step I did tells me how to factor the damn thing. Now, here's the only thing we actually have to do with fractions. We have to add these. How do I add fractions? Please, dear God, don't tell me 14/13ths. Right? What do I need?
First common
I need a large common denominator. Yes? Common denominator. So let me throw a weird phrase at you. 9 and 4 are either one of those prime. You guys remember prime? Are either one of those prime? No, because 9 is 3 times 3, 4 is 2 times 2. A prime number can only factor as 1 times itself, yes? But let me throw this phrase at you. 9 and 4 are relatively prime. Do 9 and 4 have any factors they share? 6 doesn't go in 4, and it doesn't go to 9. Do they have any factors that they share?
2.
Say again?
2.
3? Does 3 go into 4? No. Do they have any factors that they share? Only 2 and 4 go into 4, and only 3 and 9 go into 9. You with me? So here's the beautiful thing about fractions. If the bottoms are relatively prime, you just multiply each of them by the other one. He needs a 4, he needs a 9. Then they're both 36, yes? If I multiply this one by 4, and this one by 9, and I put my glasses on so I know what the hell I'm doing, what does this become?
28.
Yeah, well, 20 over 36 plus 9 times 9, 81, which is 1 over 36, yes? We're almost there. What do I do now? Let me write this again. What do I do now? Don't freak out.
Square root.
Here's the thing. Are there still fractions? I need you to realize why they don't matter worth shit. I've done The one thing we had to do, add these two fractions. Now they're just sort of sitting there. I don't have to do much with them. What do I do to both sides because of this? If I square root, what do I put? These kill each other. What's the square root of 101? I don't know. What's the square root of 36?
6.
6. And then what's the last step? Subtract 3 halves. So I get x is negative 3 halves plus or minus square root of 101 over 6. And you can stop there and that's fine. You don't have to get between those two. There's no real purpose.
Oh my god.
So, tomorrow, the first thing we'll do, if you look on the other side, we've talked about this, we've talked about this, we've talked about this. Now I have to prove the quadratic formula. So we'll do that first thing tomorrow. Sounds very exciting, Jeff. Okay, thank you for continuing to put up with me. I appreciate it.